Good day everyone, my name is Chaka Tatolo and my student number is 219-010-775. Today I will be presenting my project. The name of my project is Wireless Smart Security System, which will be using sensors for detection and ESP8266 Wi-Fi module for real-time response. So the research question for my project is that, can a wireless security system be effective in measuring real-time response for fire hazards, unauthorized intrusion, and gas leak detection in buildings? I'm sure one person might wonder, why is this important? Okay, let me explain. I'm sure we all know that traditional security systems often lack real-time responsiveness, and as we all know, in emergencies such as fire hazards and gas leaks, every second counts. This is how the project will be set up. MQ2 gas sensor detects smoke and gas. Ultrasonic sensor detects motion and unauthorized intrusion. Fire sensor detects fire hazards. DC water pump helps stop fire by sprinkling water. Servo motor opens doors for ventilation. Buzzer alerts when threat is being detected. LEDs. We will be using two LEDs for this project, the green LED and the red LED. Green LED indicates safety and the red LED indicates danger. LCD screen displays warning signs on the screen. ESP8266 Wi-Fi module sends data to ThinkSpeak wirelessly for real-time response. The project will be operating in the following manner. Under normal conditions, the green LED indicates that the system is safe and no intrusion building safe message will be displayed on the LCD. Upon any smoke detection, MQ2 sensor will trigger the buzzer and also turn on the red LED. Smoke detected message will be displayed on the LCD and the smoke level will also be displayed. When the ultrasonic sensor is detecting any motion, it will trigger the buzzer and motion detected message will be displayed on the LCD screen. In conditions of fire detection, the fire sensor will also trigger the buzzer and the servo motor will rotate 90 degrees as an indication that the doors or windows have been opened. The DC water pump will also serve as a response mechanism for fire detection, and fire detected message will be displayed on the LCD. ESP8266 will be sending real-time updates to the ThinkSpeak after every sensor detection. So I'm sure we can conclude that the wireless system is effectively reliable in detecting gas leaks, fire hazards, and motion detection, and it is also giving early warnings. Real-time alerts were displayed from the graphs on the ThinkSpeak, and this proved that the system is practical and measurable for smart building usage.
In this session, we're going to be demonstrating our circuit. As you can see here, we have our code together with our ThinkSpeak. There hasn't been any updates on the ThinkSpeak, but as soon as this session ends, there will be updates because we will be detecting threats on our sensors. Here we have our circuit. We have the servo, which will be serving as the door. We have our ESP8266 Wi-Fi module, which will be updating our ThinkSpeak. We have the ultrasonic sensor. We have fire sensor together with MQ2 gas sensor. We have our Arduino board. We have our relay module, which will be working with our DC water pump. We have our 9 volts battery, which will be supplying our DC water pump, and then lastly here we have our LCD screen, which will be displaying warning messages. As we start resetting our Arduino board, as soon as it turns on, the welcome to the planet message will be displayed on our screen. As you can see, it has been displayed, and then after this message we're gonna have no detection and built-in safe message displayed. As you can see here, there hasn't been any detections. The building is still safe. So we're gonna start by demonstrating our ultrasonic sensor by simply exposing our hand to in front of the ultrasonic sensor, and then the buzzer will start ringing as soon as it detects motion, and then our LCD screen will be displaying motion detected. As you can see, as we move our hand closer to the ultrasonic, motion detected message is displayed, and then also our buzzer starts ringing. But as soon as we move our hand away, the buzzer will stop ringing, and then built-in safe message is displayed again. Secondly, we will be demonstrating our fire sensor by simply exposing fire to our sensor, and then the servo will rotate 90 degrees as an indication that the doors have been open. Meanwhile, our DC pump will be releasing water, and then the LCD screen will also be displaying fire detected message. As you can see, as we soon expose fire to our sensor, the servo rotates 90 degrees, the DC pump releases water, and then fire detected message is being displayed. Meanwhile, our buzzer is still ringing. But as soon as we stop, the message will go back to no detection, and then our DC pump has also stopped releasing water. Meanwhile, our servo went back to 0 degrees. And then lastly, we're gonna be demonstrating our MQ2 sensor by simply exposing smoke to our sensor, and then the LCD screen will be displaying smoke detected together with the smoke level, and then our red LED will be turning on. Meanwhile, our buzzer is still ringing. As you can see, as we soon expose smoke, there will be smoke detected message on our LCD screen together with our smoke level. But as soon as we move it away, the message will disappear, and then the buzzer stops ringing also. And then here on our ThinkSpeak, lastly, as you can see, our gas level has been displayed because it has been exposed to 2 different gas levels, smoke levels I mean to say. And then here fire has been exposed, and then there's been updates, but as you can see now, it has went back to normal, which is 1. And then here we have our motion detection. All these sensors have been updating the ThinkSpeak after each and every 15 seconds, as you can see according to my time frame.